Hello, everyone.
Hello.
We will give a short introduction in just a moment, but we'll just give a little bit more time for people walking in. And then after that, we will have our presentation by Antti, who will be talking about Spine Toolbox and its exciting new features. And that will take about 45 minutes, and you will be able to ask questions just during the webinar, so you can interrupt him whenever you want. So maybe I'll also mention that the video will be recorded, if I'm not mistaken. Yes, we see it's being recorded. I'd say let's not, if you feel withheld of asking a question, don't be, just ask your question, and if you feel it was stupid and the answer was stupid or whatever, you can notify us and we'll try to cut it out of the video once we will put it available somewhere. Well, I'll take some pen and paper to try to make notes about who and when, and then we'll see what we can do. But in generally, I mean, you're used to having recorded meetings, right? Okay, so let me just, in general, then introduce these webinar series. So we have Spine Tools, which we have been working on through the European funded Mopo project. And we've been working on the past 3 years on it. And now we want to show off some of the things that we've been doing. And we will do that over a longer period of time with some 2 webinars per month, basically, until the end of the year. And it will be webinars like these, where we will talk about some certain features. Sometimes we'll also have a bit more of a user meeting where you can ask more about the troubles you were having with the tool. That's about once a month, and that's part of this webinar series. We also have some series dedicated to some case studies that we are using these spine tools for, and that will be more towards the end of the year, towards the fall. Basically because we are still working on that, but hush. And then we also have some in-person events. One is already coming up in May, and it's only in person. That will not be in hybrid format. And there is some registration link on the website or in the GitHub page of Spine Tools, where you can find all of this. And we also have an event, in-person event towards the end of the year, but the format of that is still to be decided. Yeah, we'll see how that goes. We'll keep you informed, and if you subscribe to the mailing list, you will be able to see that. But for now, I thank you all for being here, and I'd say let's get the show on the road, and I'll give the floor to Antti, who will be talking about Spine Toolbox.
Right, thank you, Tars. So I'm Antti Soininen, one of the main developers of Spine Toolbox. And this installment is getting started with Spine Toolbox. Maybe I'll show you some slide-like stuff here. First, I hope all can see my screen. Shout out if you trying to share
I can
my
see
screen.
it.
Yes,
Right.
yes.
Thank you. Is there anybody here who has never used Spine Toolbox or never heard about Spine Toolbox? I'm wondering how high or low level I should keep this.
Can you just, do we have to
Yeah.
enable people of speaking, or can they just?
I can test. Do you hear me?
Yeah, we can hear
Yes,
you.
we can hear you.
Yes.
Okay.
So I think everyone can say something. I've never used it before. I just I've heard of it, but I've never used it.
Okay, good to know. Then I can keep it low level here. Let's see. So Spine Toolbox, it's an open source Python application to manage your workflows, data, and scenarios, especially written for modeling and simulation purposes. But as you will soon see, you will be able to run all kinds of scripts and programs in Spine Toolbox. I'm not gonna keep this as a slideshow too much, so let's straight jump into Spine Toolbox. This is the main window of Spine Toolbox when you launch it the first time. For those who have been using Spine Toolbox before may notice it looks a bit different, and that's because this is a development version. We have just implemented light and dark themes to Spine Toolbox, so the coloring of different components here is slightly different from what you may have been used to. It's pretty standard interface. Maybe something to mention here is that almost everything has undo and redo actions. So whatever, if you feel you made a mistake, you can always undo whatever action you just did. And in the help menu, there is user guide available. So it will take you to your browser and load our user guide, which sometimes gives answers to your questions. If you still need some help, our GitHub page, the Spine Toolbox project, has discussion forums. We also have a Gitter chat, which has a link here in the README file. And of course, you can open new issues in our issue tracker here if you ever run into something you want to report to us developers. Right, the interface consists of these so-called dock widgets. You can resize stuff here as you want if you find something is too small, too big. You can move stuff around. Your mates may be even too flexible because sometimes people get lost here. You might, for example, close one of these docks accidentally. So there is luckily in the view menu an option to restore everything back to normal. Toolbox works, or the workflows are called projects in Spine Toolbox. So I'm gonna open one of my previous projects. Let's just open from the recent so I don't need to go through my hundreds of different test projects. Spine Toolbox project is actually a directory, so right-clicking anywhere on the design view here in the middle gives a pop-up window menu where I can open a file browser, and it takes me to the so-called project directory. And it's a regular directory where you can put your data file scripts, whatever is needed for your workflow. The idea here is that you can, for example, zip this directory and send it to your colleagues, or maybe share it as a Git repository in GitHub or Zenodo or whatever. So you can kind of package everything, your workflow and the data in a single package and share it with everyone else. What makes this a Spine Toolbox project is the .spine toolbox directory that contains a project.json file plus some additional directories. And once you create a new project, Spine Toolbox will create these necessary files for you. What's next? I need to consult my slides. So I was planning to demo you a POMO example, which is called the diet problem. It's a simple optimization problem where we try to optimize the costs of foods, stuff we eat daily, based on their nutritional content and cost and volume. So we will need things like foods, different foods that are available, different nutrients in each food, and the kind of the amount of each nutrient a person needs daily. Some of them have maximum limits, like we probably don't want too many carbohydrates per day. So let's start building a workflow that we can use then to actually solve this problem for us. By the way, I forgot to say that you can interrupt me at any time if you have questions or comments. So what we need to first do In the project directory, I have an Excel file here which contains most of the data that this model needs. So as you can see, it's a spreadsheet having 3 sheets. One of them has all the available foods, mostly some junk food and costs and volumes for each food. Then there is another sheet which contains the different nutrients which we are interested in here. The minimum amount daily consumption, and as I said, carbohydrates, you probably, or I think this is carbohydrates, who knows the maximum amount. And then there is one relationship linking each food to a nutrition, telling how much calories a cheeseburger has, or how much vitamin A is in a cheeseburger. Anyway, we will need to we will bring this data to a Spine database. Spine database allows us to create scenarios and allows also us to run different scenarios for this PMO model. So let's start with that, kind of the input side of things here. And to bring a file in Spine Toolbox, we need a data connection which acts kind of as a link to external data. Let's call it input file. So I just dragged and dropped the data connection from the toolbar to the design view. It's showing me this little red exclamation mark, which means that there is something wrong with this guy. It says this data connection does not have any references or data, which is true. We have to tell the data connection to link to some file. So on the right hand side you see this properties panel, which is now showing the properties for the data connection. And there is different kinds of stuff you can link here to. We just need to link one file path, which is the Excel file I just showed you. Other things you can link here is file patterns. If you have a bunch of CSV files which have changing names or the number of these files changed, then this might be a good use case. You can link direct to directories in your system and to database URLs as well. If you have your data in a PostgreSQL database or in MySQL database, you could use this guy here. Then we need a place to store the stuff. The data store here acts as a link to a Spine database. So let's create one data store here, call it input. It's also showing the error here. It's saying that the URL is not correctly set. We will set it up. Spine database is actually an SQL database. So currently supported SQL databases is SQLite, which is just a file on your computer, or MySQL, for which you would need a MySQL server running somewhere. We will just create a new SQLite file from the new Spine DB button. I already, of course, have everything here, so I will overwrite the existing file. Double clicking the data store opens database editor, which shows the what's currently in that database, and it's empty, except everything is white here. I mean, that means it's empty, except there is one thing in the database, and that's the base alternative. It's kind of it's kind of for the baseline data, as it says base alternative. Okay, now we need to bring in the Excel file to this Spine database, and for that we need a kind of a rule set how to turn these Excel sheets to Spine data, and that can be done by an importer item. So dragging and dropping an importer here. Let's call it import inputs. Say OK, and then I can link these items to each other from these little white squares. It doesn't matter where I link these things. I misclicked. Sometimes people ask, well, how should these guys be linked? And it doesn't matter. And there can be any number of links between the items here. So what now happens is that the Excel file provided by this data connection goes to importer, which then should know how to write that Excel file into a Spine database. Well, currently it doesn't. It's saying that this importer does not have a specification, which means that it's missing the rule set I was talking about. So let's make one. Double-clicking the importer opens something called the specification editor, where we can edit the rule set. But first we have to select what type of file we are gonna, or what type of tables we are going to import here. Supported tables are CSV. If you have a single CSV file, this is fine. Data package is a way to package multiple CSV files into a single data source. So if you have multiple CSV files and you choose to make a data package out of them, each CSV file will come out as a separate table for the importer. Then the Excel comes GDX. There is some support, very limited support for JSON files, and then you can import tables from an SQL database. So let's do the Excel import. Now on the left-hand side, we have all the different sheets we had in the Excel file. There is the foods, nutrients, and nutrient contents. Now the order here matters.
Can you full screen the importer?
Sure.
And perhaps zoom in a bit, because it's a bit small.
Yes, it's a bit small, so that's true. So let me try something here first. It's actually I should have done before, but forgot. I should have asked this first. Where is it? So let's scale. Better?
Well, let's see the table and see whether that's better.
I hope, yeah, it should be.
Yeah, look, already looks better.
Okay, good. Yeah, I should have done this already before I started. Sorry about that. I hope everybody could see at least some of the stuff I was showing there. And thanks for notifying me, Tars. Yeah, as I was saying, the sheets are here. Now the order matters here. So we can drag and drop these tables around in the list here, which is also the order in which they will get imported. So we need to first import all foods and nutrients before we can talk about the relationship between these two guys. If we try to import the contents first, we would either be missing the foods or the nutrients needed to build these relationships. Okay, in the middle, you can see a preview of the Excel table. So this is real information from the Excel file. On the right-hand side are the actual rules, the rule sets to import the selected table. And these are called mappings. You can have more than a single mapping here if the table contains more data than just, well, if it contains different types of data, but this guy contains only a single data. Let's say that it's mappings for foods. There is different kinds of things you can import from the data. We are going to import something called entity class. This table contains a parameter, or two actually, cost and volume. So we say that we are going to import values and single values. So it's just both cost and volume for each food stuff is just a single number. You could also import stuff like time series if, let's say, the cost of cheeseburger changed in time. The rest I'm gonna skip. And then there is this colorful table at the bottom, which actually is the actual rule set. First, we need something called entity class name, and this is actually the food here. Our entity class is called food. And it's in the column header of the first column. So let's say that we are picking it up from the column header, and importer automatically guesses that you are taking it from the first column. Now I actually noticed that I don't have a header here, so I have to tell at the top of the table there is this little extra options, and I have to tell importer that, hey, by the way, this table does have a header. So now you can see that this first row is now being used as the header here. Then we need entity names, which are actually the foods here, the concrete foods, let's say. And we need to pick them up from the first column. So if I just enter number 1 here in the source ref, importer will just guess that, okay, you actually mean a column here. And now you can see that the yellow color used for entity names here is also used to color the first column here. So that's kind of a visual cue for you to see that, yeah, now I'm picking up the correct information for the entity names here, or in this case, the foods. Then we need alternative name. We are just going to use the base alternative I just showed in the database editor. We know that this exists, this alternative exists in the database. And now when I write that in the source ref, importer will guess that, you must be meaning a constant value here. So everything here is imported into the alternative called base. Then we need parameter names. We have 2 parameters here, cost and volume, and these are in the headers. So let's say that pick them up from headers. And when I select headers for the source type, you will see that the parameter values get set to pivot. And this is the blue or greenish value color here. That's it. Looks good to me at least. And then we would do the same for the rest for the other tables. I'm not gonna do that here. Instead, some stuff has happened here. Instead, I'm going to use, I already have set up those rules for the importer, so I will be using these known working and known rules. So double clicking the editor again, and then checking that, okay, there is color in the middle, so the rules I have set previously look okay. All right, then we actually have something to already run here. So selecting the import input item here, and then going to the toolbars again, there is the execute toolbar here. And there is execute selection button, which will execute that one importer for us. Now, if we observe what's happening in the event log here at the lower left screen, there is this box that actually now is printing the output from that importer. And it said that it inserted 176 data with no errors, which is nice, into the SQLite file. Okay. Now we should have some data. Data here. So double clicking the data store opens the database editor, which now has some data in it. Nice. So on the left hand side here, we see now all the different so-called entity classes. So our entity classes are food, nutrient, and nutrient content. Nutrient content being the relationship between the foods and nutrients. In the middle, this is called the table view. There is 4 different tables. There are parameter values, which show, for example, for cheeseburger, the cost in the base alternative, and also for cheeseburger, the volume in the base alternative, something like that. There is another table which defines the parameters. I mean, just that these parameters exist. Their actual values are in the parameter value table. And then there are some other tables which we will look later on. There are other views available in the database editor. So now we were in the table view, and gonna next show the graph view, which builds a graph of our data. Unfortunately, as you can see from the mesh on the screen, this particular model isn't very nice for the graph view. Generally, I would say the energy system models with their units and nodes tend to be more visualizable here in this view. We can help this situation a little bit by giving some color to this view. If I go back to the entity tree on the left-hand side, right-click on the food entity class and then selecting edit, I can change the display icon. Double-clicking that guy. So this is some junk food. So let's give it some junk food-like icon and choose some appropriate color for it. And then pressing OK and rebuilding the graph. It doesn't help much, but at least you can now tell where the foodstuffs are. Selecting a bit less stuff is maybe more helpful, but still there isn't too much information gained in this particular case from the graph view. Sometimes it's useful though. Then you can also view.
Antti, there is a question about.
Sorry, I don't see questions. So
yeah, that's why I'm notifying you.
Okay, thanks.
And you can interrupt the presentation as well, so you can unmute and ask your question yourself. But Shane asks whether you can specify the location of each entity on the screen using a column value. Or just, whether you can specify the location of each entity in the graph, I suppose.
Yes, I suppose that's the question. So actually, if we go to the entity table, so down here in the middle, this is the same entity table that was in the table view, which I didn't, by the way. So in the entity view, there is actually, as you can see, there is latitude, longitude, and altitude data available for each entity. So you can actually store the coordinates here. For example, for cheeseburger, I can right-click it and select Save Positions, which adds the positions here. This graph view is using Mercator projection. So in theory, you could show your stuff kind of geographically, your stuff here in the real geographic coordinates. You could even add a background image. Now I'm going out from the actual, maybe I shouldn't be doing it. Select background image. So you could add here a SVG file if somebody recognizes that as my home country. So maybe iron is found here and calcium here and cheeseburgers are available somewhere in the Oulu region there. Yeah. Now I need to save the positions again. Actually, I should then select all these. All these guys for. No. Okay. Does that answer the question?
For me it does, but we'll see
if there are further questions. So yeah, we do support geographic coordinates, plus there is an option to add shapes and shape blobs for GeoJSON basically to each entity. So we do have some support for GIS data here. Right, where was I? Okay, let me know if there was further questions. I'm going to switch to pivot style view. So as the name says, pivot is a pivot table. For example, for foodstuffs, you can view the parameter values here in a pivoted view. You can do lots of stuff here, like drag and drop the headers around to change how this table works, kind of change the dimensions of the table to your liking and such. Not going to go too deep into that here, but just to show you that there are different views available to help you kind of find the best view for whatever you are currently doing. Then I need to check out what I was going to do next. So we are still missing one thing here. And that is no. So what we are missing here is one constraint for the model, and that's the maximum volume of food you can consume daily. And that one didn't exist in the Excel file, and that's why we need to now add it here manually. So just to show you how to add data with the database editor. So first we need a new entity class for that. So right-clicking in the entity tree root and then selecting add entity classes opens this add entity classes dialog. All these dialogs have this kind of tabular view where you add the data. The idea is that if your data is, for example, in an Excel file, you can copy paste your data directly to these kinds of views. So this one should be called constraint, I think. I could add a description for it and choose a display icon and the rest of the things I'm not going into here, but that's enough for us now. Clicking OK adds us a new entity class here, constraint. Then we'll add a new parameter for that. So I'm going to the parameter definition table. And then there is this empty row, which is used to add new data to these tables. And already the class column has the correct entity class because I have selected it in the entity tree. So let's call this parameter volume max. And when I press enter, there is already enough information to add this row to the data structure. It's not in the database yet. But we have now created a parameter called volume max to the constraint class. Then we need to give a concrete value to this parameter, and for that we need an entity. You can create entities from the right-click pop-up menu, either add entities or by this little icon here. So if I click that icon, it will open the add entities dialog, which is very similar to the add entity classes dialog I showed just a few minutes ago. So this can have any name, I think, but let's call it diet. And now we have an entity called diet in the constraint class. So let's go to parameter value table. It's empty for the diet. So the diet entity does not have any parameters yet. Parameter values yet. So let's add one. The class column already has the constraint. Entity by name already says it's diet. Then we need to tell which parameter. So double clicking that cell here gives me a list of options. The only parameter in the constraint class was volume max. Then we need to select an alternative. The only alternative we still have is base. And then we have to give it a value. So let's enter 75 there just to make sure. 75 it was. And that's it. Now on the top here we can see our just added parameter. Now we should maybe save our changes, but since this is a database, not a file, even though it's backed up by an SQLite file, save action is actually called a commit. So let's commit, select commit there. You're asked to give a commit message. Let's write something there and say commit. So now our data is in the database, which means this parameter value plus actually those coordinates for which we saved in the graph view. Right, now we have the base model is there. We have all the information. Let's start building scenarios. And scenarios they consist of alternatives. So on the top right hand side, we have our list of alternatives. We still have the base alternative. Let's put a few other alternatives here. We could start in a case where milk is somehow expensive. So let's make a new alternative called expensive milk, which probably means now if we go to low fat milk here, the cost, there should be a more costly milk available. So let's add a new parameter value for that. Say the cost in the expensive milk alternative is double what it is in the kind of the base. Base case is here. Now we added a new parameter in for the expensive milk alternative, which is twice as expensive. Probably also the price of cheeseburgers increases. So let's say it here. So we create a new parameter value cost for cheeseburger cost, and let's say that cheeseburgers, when milk is expensive, they cost 2.5 euros or whatever currency you prefer here. Now we have two alternatives. We can now start creating scenarios. Probably we first want to have a baseline scenario. So in the middle here on the right hand side, we have the scenario tree. There is currently no scenario, so let's make a baseline scenario here. And the baseline scenarios consist of alternatives, and the baseline scenario consists just of the base alternative. So every parameter value that says alternative as base here is included in the baseline scenario. Now it excludes then, of course, this expensive milk guys here. That's our kind of default scenario. Then we need to make a scenario where we actually use this expensive milk stuff. So let's call it milk crisis. And milk crisis starts from the base alternative again. It gives us all the base prices, base costs, every base stuff from the base alternative. But then we will overwrite these two cost parameter values for low fat milk and cheeseburger by dragging and dropping expensive milk here below the base scenario. So alternatives here in the scenarios alternative list, they overwrite each other such that things on top will get overwritten by things at the bottom. I hope that's clear. Okay, so one thing you can use to build scenarios here with alternatives is to change parameter values. The other thing you can do with alternatives is to control the activity of entities, which means that you can hide or show entities depending on an alternative. And that's what we are going to next do. So let's imagine a world where Belgians never invented fries. Let's make an alternative called no fries. So yeah, a world where there are no wars, no conflicts, and everybody has fusion power available for them. And now to use this no fries alternative for this so-called entity activity control, we go to the entity alternative table in the middle. And what did I say? Fries. So I select fries from the entity tree. In the no fries alternative, these are turned off. And then we can build a scenario out of that. Let's call it fryless bliss. And again, we want to start the scenario with the base alternative, just to bring in all the data we have there. But then we want to kind of overwrite the activity of fries by dragging and dropping this no fries alternative in the alternative list of this fryless bliss scenario. We can actually check which entities we have available in each scenario in the entity table. So in the middle, if I jump to the entity table, you can see a list of entities here. And now if I select the fryless bliss scenario, you see that fries are missing in the food entities. Now, if I select any of the other scenarios, you see that the fries appear there. So this actually shows you the activity, real activity of each entity in each scenario, each selected scenario. Okay, that's it. Now we have 3 scenarios. We have the baseline, milk crisis with higher milk prices, and fryless bliss where we don't have any fries available. Let's commit the data. So press the commit button, write some nice descriptive commit message. We have, if you're wondering where those commit messages go, we have history available. So in the session menu item, there is history from which you can then check out the previously added things or change things. This is not perfect list because it doesn't show you things that were removed or were renamed or updated in some other ways, but you can still check at least the commit messages from here. Okay, everybody still with me? Everybody alive? I think we can close this guy and move on to the next slide. We did build scenarios, so let's finish the workflow. That's not the right window. This is. So as I said, we have built now kind of the input side. Next, we need to build the side of the workflow where we actually solve this model. And for that, it's gonna be, the model is a Python script. So we need a way to run a Python script here. Usually you would use a tool item to do it. I have already set up the correct tool, so I will just drag and drop the ready-made diet problem tool here to make this a bit faster. Then I will connect the input data store to this diet problem. And now there is some interesting stuff happening if I select the link arrow, the yellow arrow between these input and diet problem nodes in the workflow. And that is the link properties now actually shows the scenarios here. The baseline scenario, fryless bliss and milk crisis. So from this you can select which scenarios you want to run. What Spine Toolbox does, it runs the, in this case, the Python script, because we have 3 scenarios, it will be running the Python script in 3 different processes, separate processes in parallel. So we will get the result at the same time for this particular problem. So let's see how this, actually what we also need to do before we go into that script itself, we need a place to store the results. And for that, we need to create a new Spine database. Let's put a data store here. Let's call it results. It's again saying that it doesn't have the URL correctly set. We are gonna create a new Spine database overwriting my previous results. And then we're gonna connect the tool there. Okay, now we actually have something that already looks like a real workflow here. So there is an data input here. There is the actual model in the middle, and then finally there is place where we store the results. So double clicking the diet problem tool opens a so-called tool specification editor, which now specifies what this tool is going to do. So first of all, top here on the top left corner, there is the name of the tool. There is tool type. It's gonna be a Python script. We directly support Julia scripts as well, YAML stuff, and with executable you can basically run anything like an R script if you have an R interpreter installed on your machine. Then I have to, because I'm running Piomo, I had to create a Python environment for Piomo, and then I need to tell this tool that, hey, by the way, from my Python environments, pick up the current environment and use the current Python interpreter there. Then I have set up this tool to use this diet.py file. It can have many more program files. I mean, if your tool is actually a big project, you need to add the rest of the source files here as the additional program files. Tools can have input files, output files here. But this one is not gonna use them because we are actually going to read the input database directly in the script, and then we are going to directly write to the output database. Your tool might be using, let's say, CSV files or Excel files. So you would then need to perhaps add those here as the input and output files. Anyway, in the middle, we have the actual contents of this diet.py. The first part here defines the model as a Piomo abstract model. So it's just a mathematical representation of the model. I'm not going to go much deeper into it. We don't have time for that. But it's, as I said, it's just an abstract mathematical representation. So what we need to do here is to fill the model with the data from the input database. And for that, we are going to use SpineDB API, which is a Python package for reading and writing Spine data. It's a higher level package than just using SQL commands directly. I don't recommend trying to read or write Spine databases with SQL because they're actually a bit complex. They're more complicated than just straight out tables in a database. Now, two things. To read and write the databases, we need the database URLs, and those we are getting from command line arguments, which should be supplied by Toolbox. We need to actually set them up now before I forget. So I'm gonna minimize the editor. In the toolbar properties on the right-hand side, there is this tool arguments list here, which we should now populate with these URLs of the input database here and the results database here. So these are actually listed in the available resources list here. So let's just drag and drop them there. And that's it. Now when Toolbox runs the script, it will provide the URLs of the input database and the result database as command line arguments for this script, which then reads them here on these 2 lines of Python code. I think I should maximize this guy. Okay, then we use database mapping from Spine API with the input URL to read the data. I'm not gonna go into details here. We end up with this Python dictionary that's compatible with Pyomo. Then we create a model instance by filling the abstract model with the data we just read from the database. So it's done here with this create instance. Then we pick up a solver. I'm using Heis here, and then the magic happens behind this otherwise pretty innocent looking line of code. Finally, we need to store the results to the output database. Again, we use the database mapping from Spine API using the output URL provided by Spine Toolbox, and then we just write the data. I'm not going to go into details there. Maybe something worth noting here is that nowhere here anything is mentioned about scenarios. So this script does not know which scenario it's going to be running. The scenario information is actually provided inside the URLs here in the input URL. And database mapping, it gets the input URL and then it knows how to kind of filter the data correctly for you, how to pick up the correct cost for cheese and for low-fat milk and cheeseburgers, how to turn off fries in this fryless bliss scenario. And it's transparent to the actual script here. Maybe the only thing that hints that we are running different scenarios in parallel at the same time here is the fact that first of all I have to lock the database before I can write to it, so that no 2 scripts or 3 scripts are trying to write the same database at the same time, or read and write the same database at the same time. Plus, I need a unique name where I store the results. And to get that unique name, I use an alternative that's given me by Spine API. Nothing except that here points, especially in the reading side, there is nothing that hints to any scenarios anywhere. Okay, I think we are ready to go, I hope. So selecting the diet problem item here and then going to the execute toolbar, execute selected items. So let's see what happens. The hammer starts to hammer and let's hope it ends up in bliss. Okay, so the little mark here shows that the execution has been completed and even completed successfully. In the event log on the lower left corner, you see these little boxes showing some output from the tools. Maybe the most interesting thing is that this last line is green and it's saying that execution has finished. Now the consoles doc here show Python consoles for all the scenarios. So you can actually, now the script didn't print anything here, so these are pretty boring, except if you want to do some post-mortem debugging, you could, because this is the same same console that was used to run that script in that scenario. What I can do here is actually, now let's go fileless, please. And I can do in postmortem debugging here. So there was the concrete instance of the model which contains the parameters. I can print it out. And it prints a lot of stuff here, of course, but maybe the interesting thing here is that when we look at the available foods, there is no fries here. So in this fryless bliss scenario, as I said, we will turn off fries, so they didn't end up in the actual model. Great. Let's have a look at the results. So selecting the result database, double-clicking it, opens the database editor. There is just a single entity class here called results. We have the results here. Let's select them. These are not single values anymore, but something called a map, which is kind of a multi-dimensional parameter value. Right-clicking the value, I can select plot here, which plots the results. So this is our optimization now. If we look at the blue line, which is the baseline scenario, if you want to save money, you should eat 4 cheeseburgers, 1 fish sandwich, and 5 fries a day, and drink 4 glasses of milk. And if Belgians never invented fries, we should look at this brown or orange line. So you would still eat 4 cheeseburgers, but because there is no fries, you would instead eat 2 fries, 2 fish sandwiches, and replace 1 glass of milk with 1 glass of orange juice. Cool. If you wanted to do more analysis, you could export the data by dragging and dropping an exporter here. This works similarly to importer, but the other way around. So you could write an Excel file or some CSV file, which you could then run through your normal analysis software. You could drag and drop here a tool that uses a large language model to write a report or even a journal paper for you from the results or whatever. I mean, you could extend the workflow as you want. And that's basically it. Any questions this far? You have been awfully quiet. I hope I wasn't going too fast. Yeah.
It seems that Shane has another question. You can just unmute.
Yeah, please.
Oh, yeah, thanks very much for that. Yeah, just more wondering when you're specifying the lat long location of an entity on screen, can you do this at the import stage, or does this need to be set after you've imported everything?
Currently, you have to do it later because there is no, if I remember correctly, there is no support yet for locations. No, so it's not yet has not been yet implemented. Of course, if you have the locations in an Excel file, you can just copy paste them here, so you don't need to manually write all of them. But yeah, we are still missing the support for importing these using importer. Other option would of course be to have a tool here that specifically imports that stuff using SpineDB API. But yeah, it's currently missing feature in importer, as well as in exporter you can't export location data.
And just very quickly, just in terms of setting directories for your input or your export files, are they by default relative to the path of where the, let's say, the project file is specified, or can you set absolute like UNC paths?
It depends now. Data connection by default, data connection or stores these paths. For example, this one we used here. The file is inside the project directory. So this is actually this reference is actually stored as a relative path. However, if this Excel file would have been outside the project directory, then Toolbox uses absolute paths.
Thank you.
Is that clear? However, there is an option. So in File, there is this project settings, which has an option called Store all paths as relative to project dir.
Good to know. Thank you.
Which, yeah, I know there are some cases where they prefer having so this basically means that everything is always stored as relative path.
And then we have also a question from Leonardo.
Yes, please.
Hi, yes, thank you for a presentation. I have used at the beginning Spine a bit a few years ago. Then I decided it was still not so developed to be used. Something that I've always found was missing. It was to have a set of examples of projects, simple projects to put their hands on and try to modify them. And as far as I have seen now, I don't see any in the GitHub. Maybe I am not seeing them, but
it's something. I mean, we are still at the same stage. We still have just the getting started, which is very simple.
Yes, okay. Why not to do that? I think that you have, I mean, obviously not to share projects that cannot be shared, but maybe I think it would be very, 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 very useful to have, I mean, just a simple example of wind plus PV plus load, something like that was already available, for example, in the Arena Flex tool. Something, it would be very, very, very good to start working and then understanding.
Right. Spine Opt does have a bunch of tutorials, I think, and also I hope we will add more Toolbox tutorials, but those will be maybe more geared towards setting up importers and exporters here. But yeah, we have recognized that kind of missing feature. We should have, at least for Toolbox, we should have more tutorials, especially this kind of simple use cases. I hope I could turn this webinar into a tutorial one day.
Yeah, but also have the files available, I hear. That not only in written text and in describing how to do it, but also already have some files available. In SpineOpt, we now indeed have that. We also used to just have text, but now in SpineOpt, we also have these JSON files, which can be directly imported to Spine Toolbox. So something similar on Spine Toolbox side is worth noting, which I also did just now. So we'll get back to that at some point.
Right.
Okay.
Thank you.
Further question is still possible, but I'll now also give already the outro such that people can leave if they want.
I had still one little thing, if you allow me.
Okay, fine.
Just quickly the last slide, because if you got interested,
right,
Toolbox can be installed on your machine, hopefully. If you're on Windows, the easiest way to install Toolbox is to download a zip bundle from our downloads page, which is here. There is, well, you just probably want to pick up the latest guy. download it, unzip it. It contains a Spine Toolbox.exe file which you can just start. So it's not an installer, but kind of a standalone package of Spine Toolbox that you can directly use. You don't need Python for that. If you have Python, you can either use pip or pipx to install Spine Toolbox, following the instructions in our README file, which is a bit has too many words, but still, yeah. So these are the easiest ways to get your hands on Spine Toolbox. And well, okay, now Tars, you can.
Yeah, and that brings me right to the next session. Next week, we will have a session about Spine Opt more, but more the data structure. But the session itself is actually more of the typical Spine Tools user meeting that we had before. So that's where we help you when you have issues. So if you indeed got interested and installed Spine Toolbox, but if you have some issues with that, then next week is the place where we can already help you with anything Spine Tools related. Could be Spine Toolbox, could be Spine Opt. So yeah, then you can go there. And we will also introduce that session with then the new Spine Opt data structure. So that will be mostly interesting for people who already have been using Spine Opt, but also for new people who want to know how Spine Opt will look like. But the basic use of Spine Opt will be in a further webinar down below. The schedule is on the website. Yeah, and so we'll see you hopefully there, or some other people. We'll see. I think that's the most important part for the next parts. And yeah, well, if you're subscribed to the mail list, we'll send you another mail about what the next topic is and what will, or whether there are changes in the event series. But that being said, I thank Antti for the nice presentation. Despite his offensive scenario on no fries, because I'm a Belgian, by the way. So, but it was still good to follow, despite that. And then I also thank you all for being here and having been part of this, and hope to see you next time. If there's still a question, you can stay here, and otherwise you can have fun somewhere else.
Thank you very much.